Hello, my name is Dave Rollins, Engineering Manager for MH&W. In this video, you will learn how to set up and test our CoolBLUE cores with a Rogowski coil and a Handtech digital scope. First, we remove the Rogowski coil from its case, along with the 20-inch BNC adapter cable, the PAM integrator unit, and the 4 AA batteries. Next step is to go ahead and insert the AA batteries into the back of the integrator unit. We like to keep these batteries out of the unit when it's in a storage case because the power button, which is right there, is real easy to depress, and while it's in storage it can accidentally get turned on. And so when you go to use your unit the next time, you'll find that you have dead batteries. So we highly recommend that after every use you remove these batteries from the integrator and put them back into the case. So we do it like so. And one thing to note on the back of this integrator unit, the oscilloscope is going to measure the current in volts. So we have to know what the conversion is from volts to current. And on the back of your integrator unit, you will see a sensitivity level. And you will see that this is rated at 50 millivolts per amp. So for every 50 millivolts on the oscilloscope, you will have 1 amp of current. Now we will just test it, turn the power button on, make sure you get a green light, which shows that the batteries are good. The next step is to go ahead and take the BNC adapter cable and attach it to the BNC connector on the top of the integrator. Then you will take your Handtech oscilloscope, and under channel 1, you will attach the other end, like so. So the next step is to set up the Handtech scope with the proper settings to test the CoolBLUE cores. We start off by turning on the oscilloscope. As you see on the display, we have a yellow line and a green line. The green line is channel 2, which we want to turn off. So you do this by pushing the channel 2 button, and it should toggle it off. Another method is you can simply push the F1 key where it says enable on, and it will say enable off, and it turns off. So the next step is to center our yellow line in the center of the scope. And we do this by adjusting the up and down arrows just to the right of the volts amplitude arrows in the bottom left corner of the screen. So we will lower that down, and you will see that it shows position, and it's decreasing in numbers, and we will actually go this lower it until it says position is 0. Now we are right on that yellow line. The next step is to adjust the channel 1 voltage setting so that it reads 50 millivolts. In this case, it already is there, but in case it was higher or lower, you would simply push the up and down amplitude keys in the proper direction so that it now reads 50 millivolts. The next thing we want to do is to make sure that the time scale on the scope is set to 200 microseconds. Again, in this case, it's already set there, but in the event it wasn't, you would go down here under time per division, and you would adjust the 2 toggles, either up or down, so that the time will read 200 microseconds. Now this says 200 microseconds. So the next step is to make sure that the scope is reading Vmax. If it's not already there, you would push measure, Then in the top right, you will see this F5 key. And above that, you'll see a 1/5. You'll push the F5 key once so that now it's displaying page 2 of 5. Move to the left, and on the F3 key, it says maximum. Press that once to set the Vmax on the screen. Once that is done, press the measure key to turn off the display. Now the scope is all set up, and we are ready to move on to the next step of attaching the Rogowski coil to the VFD. So in order to attach the Rogowski coil to the VFD drive, you're going to want to take the end of your Rogowski coil, and you'll see one end that appears that can be inserted into the connector. And what you want to do is you can pull this clear tubing back a little bit, but you want to fully insert the end of the cable into the connector till it bottoms out, and then you tighten the nut like so. So now we will actually take the coil, the end of the Rogowski coil, and actually loop it around your 3 VFD motor leads, like so. And just like I demonstrated earlier, you fully insert the end into the connector till it bottoms out, and then you tighten the connector. So before we start up the VFD, we want to take a picture of the Rogowski coil setup before we proceed. Now that we have captured our Rogowski coil setup, the next step is to go ahead and power up the motor by starting the VFD. As we come up to speed, we want to make sure that our 50 millivolt setting is a good setting for the total peak values of our wave shapes. You don't want them to be too big so that the waves get clipped off on the top, but you also don't want them to be too small where when we do put the CoolBLUE cores on, we don't see the drop isn't as noticeable because the wave's so small. So in this case, at 50 millivolts, I think we're a little small, so we'll go ahead and increase it so that our wave shape's just a little bit bigger. Wrong way. This is a 20 millivolt setting. We have a nice wave shape there, and I think we'll leave it at that. So now we will monitor Vmax and record the peak value. The one trick is on the right-hand side of the screen is your trigger button. And then below that is an up-down arrow key. If you move the trigger, which is the little orange caret on the side, if you increase that trigger level up, it will slow down these digits, so it makes it a little bit easier to see and to record which your peak value. So we'll set it about there. And now we'll hit the run stop key to see if we can lock on what we're visually seeing to be a peak value. Another method would be to take a video of the screen with your phone and then go back and review the video and pull out the screen of the Vmax and use that in your test report. But I have now locked on to a Vmax of 61.2. We will now need to take a picture and record this into the test report. With that information in there, we can now move on to measuring the dV/dt portion of the wave. We do this by releasing the scope, and we're going to change our time scale down to roughly 2 to 4 microseconds. And to do this, you will either increase or decrease the time per division by toggling these two buttons. If you don't know which way to go, just go one direction first and then see what happens. So as we go, we are going down, and this is now currently at 2 microseconds. I really prefer to have that wave shape a little bit spread out, so I am going to go ahead and stretch this out a little bit further, and that looks good. And we'll go ahead and grab that picture and move our Rogowski coil over onto the ground wire. As we did in the first test, we need to take a picture of the Rogowski coil setup with the Rogowski coil around the ground wire. Now it's time to go ahead and start up the drive and basically repeat the same voltage Vmax test that we just did, but now it is with the Rogowski coil around the ground wire. So we will start up the drive. Once it comes up to speed, while it's coming up to speed, we need to go ahead and change this time back to 200 microseconds by changing our time per division to 200 microseconds and verify that we are still on 50 millivolts. Again, like before, we are going to monitor Vmax and try and record the peak value that we see. I saw 50, 54. So I am going to try and hit the run stop key to see if I can capture one up in the 50s. There's 50. The other method would be to use your camera or your tablet and take a video, about a 1 minute video, and then review the video afterwards and scroll through it until you find the max value. In this case, I was able to find a 56.2, which is definitely the max value. So I've hit the run stop key, we're locked on it. Now it's time to go ahead and insert this into our test sheet. So now we'll go ahead and release it. Now we want to capture the dB/dt. Change the time back down to, we were actually at 500 nanoseconds before, so try and put it right back to the same level. And you see we got a nice wave shape. Try and look for the Vmax. The Vmax should be the same, pretty close to it, because all we did was just zoomed in on the wave. We haven't changed anything else. So again, I locked on to another 54.6. And I will go ahead and grab a screenshot of that. So that completes the testing of the VFD system before we put any CoolBLUEs on the VFD. So we'll go ahead and power down the VFD. Okay, now that we have installed the CoolBLUE cores and the NaLa cores according to the test analysis recommendations, it's time to go ahead and take a picture of our setup. But just real quick, just to show you, we have our CoolBLUE cores. We have our 2 turns through there since it's less than a 10 horsepower motor. And we have our NaLas. And the CoolBLUE cores are closest to the VFD. The NaLa cores come next. And then when we place our Rogowski coil to test, the coil is going to go in between the NaLa cores and the motor. We do not want to put it between the CoolBLUE cores and the VFD. So you can see our Rogowski coil is after the NaLa cores. So with the setup as is, we need to go ahead and document the setup. And as usual, go ahead and take a picture. Now that we have the Rogowski coil setup recorded, we can go ahead and start up the motor so we can perform the next group of tests. Once again, as the motor comes up to speed, verify that we have a good amplitude, and I'm going to leave it on the 20 millivolts per scale. I really wouldn't want to change it because we want to keep it so that when we compare the 2 pictures from before and after, we're always on the same scale. So whatever you use for the without cores, you want to use the same scale for with cores. And I've left it on the 200 microseconds. So once again, we're going to look for the Vmax. My trigger is way up here. It's way above all these peaks, so we're actually going to bring this down and see if that will help us lock onto the So now we'll hit the run stop to see if I can lock on the peak value. And I've locked on to 26.2 millivolts. As we've done in the past, we will need to go ahead and take a picture of that so we can insert it into the test report. Now that we've entered that, we can release the scope and move on to testing the dV/dt part of the wave shape. As we've done in the past, we will go ahead and decrease our time down to our 500 nanoseconds that we've used in the past by selecting the toggle key under the time per division. Once there, we'll go ahead and stop it. We will insert that picture. Now that we've captured that, we can go ahead and shut down the system, move our Rogowski coil over to the ground wire, and repeat the test process. I have now removed Rogowski coil from around the motor leads and positioned it around the green motor lead and connected it back together. So now we are ready to go ahead and take a setup picture showing the Rogowski coil around the ground wire along with the CoolBLUE cores around the motor leads. Now that we've once again recorded the Rogowski coil setup with around the ground wire, we need to go ahead and start up the VFD in the motor again. As it comes up to speed, make sure that your time is back on the 200 microseconds. And in this case, I wasn't, so I need to increase that. And we're back to 200 microseconds. We're going to leave it at 20 millivolts. And again, we're going to monitor Vmax for that max voltage. And we will lock on 25.0 millivolts. So now, as we've done in the past, we will go ahead and record that picture. Now we can go ahead and proceed to the next step, which is to measure the dV/dt of this wave shape. So we will release the scope. Again, decrease our time down to the 500 nanoseconds. Lock the scoop and take a picture. And with that concludes the testing. You can go ahead and shut down the VFD and remove the Rogowski coil from the system. If you have any questions, feel free to contact myself or the CoolBLUE team. I'd like to thank you very much for your time.